Okay, so what we're going to be doing here is we're going to be looking at the graph and then finding what is that slope. Does anyone remember what a slope even is? What is slope referring to? Yeah. Sorry, what?
Like an angle or something like that?
It actually has to do something with an angle. Are you thinking of like the line and how it's, yeah, let's see if we can fill it in.
Rise over run.
Okay, rise over run, right? So how much does it rise over how much does it run? And it can rise a little bit and run a lot, or it can rise a lot and run a little bit. So the steepness of a graph is its slope. So when you're talking about slope, guys, don't forget, slope is designated with the letter M. So if I say, what's the M? And you're like, oh, the slope. And that's rise over run. I only have one problem. If we're looking at, for example, number 25, I want to go through number 25 on page 111. Okay, looking at that graph, is it pretty steep or not super steep? I mean, how would you describe it? I think it's relatively steep, so it's pretty steep, especially compared to 24. It's more steep or steeper than that previous graph. But we got to describe it using numbers. What I want you to do right now is I want you to give me 2 points on that line. Any 2 points on the line. And I'm going to help you out with one of them. Because this is hard. It goes by twos. Each little tick mark goes by twos. 1, 8. You guys see that point? 1, 8 on that line? 1, 8. Do you guys agree with me on that? Because if we don't, we're not in a good spot. 1, 8 is a point on that line. Okay, find me just one other point. And I have to verify it because I have to look at the graph to see if you're right. By the way, how many options do you have? Infinite, but really, guys, practically speaking, you really only have like 3 or 4 because it's hard to tell like 0.25, let's see where it would be, 0.25, 5.7, I don't know, I'm guessing, but there are points that you can find, and I need someone's help on that. Philip, what do you have?
0, 5.
0, 5. Okay, 0. I think that's a point. I'm going to give that one. 0, 5. Do you guys look at 0, 5? Okay, I'm going to use that one. So 0, 5. Okay, we have 2 points, and that's going to help me to find the slope. If I use that little slope formula, does anyone remember what the slope formula was? Slope is equal to y sub 2 minus over x sub 2 minus. There you go. Put in the numbers where they belong, and that will give you your slope. That's how you're going to find out the slope, assuming your 2 points are good, which they look good.
Which number is it?
No, this is number 25. Okay, so this is how I do it, guys. I'll just show you how I do it because I don't like signs messing me up. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I put parentheses for all my variables and just put in the numbers where they belong. What's y sub 2? 5. What's y sub 1? 8. What's x sub 2? What's x sub 1?
1.
Okay, so I just put the numbers where they belong. Those numbers could have been positive or they could have been negative, so I just put them where they belong. What's 5 minus 8? Negative 3. What's 0 minus 1? Negative 1. And so what's my slope? Simplified. Don't ever make it a mixed number. Oh, it's just positive 3. So that's my slope, 3. So the rise is up 3 over 1, up 3 over 1, up 3 over 1. Right? Isn't that what we're saying? And that's what we got from our...
And never make it a mixed number?
Yeah, okay, you can, but that's not going to help you to graph it. Because it'll be like up 3 4/5 over 1. Up 3 4/5. Like, that's weird for us to do.
I don't get how you guys are 1, 8, and 0, 5.
Oh, these numbers?
Graphs for like,
The numbers? Oh, you're talking about where I got those numbers from?
yeah, the word pairs.
Yeah. Okay. So look, can you find where 1, 8 would go on that graph? That's because every one of you have to be able to do this. Is 1, 8 a point on that line?
Yes. It is.
So you got to go over, so here's the origin. You got to go over 1, which is in between the first tick mark, right? Because it goes by 2s. And then you go up 8. Is that point on the line?
Up 1, over 8.
Gotcha. Yes, it's always left and right is the first number, and up and down is the second. Always. Yep. That's a good reminder. We need that. Okay. Help me out with number 27. So go ahead and find that slope, and we'll confirm whether you got it right or not. William, can you give me a point on number 27? 3, 0. Oh, man. I think it's close to that, but do you see how it's a little off? Give me another one that you could be like, that's it. How about 27, sorry, I was looking at the one. 4, -6, that's a good one. That's a good point. 4, -6. 4, -6. Yep, that's. I like getting points that are at intersections on the grid. Right there on the intersection, that's an easy one to get. Can someone give me another point? It doesn't matter which other point as long as it is a point. Alex?
2, 4.
2, 4. Yeah, I'm good with 2, 4. Now, Mr. A, what if I found 2, 4 first, then I put 4, -6? So I switched them around. So what if I had like this, right? Can I still use the formula the same way I use this? And the answer is yeah. They come out to the same numbers. And if you want to test it, try it. I'm going to use it this order. Can someone try it the reverse order? Can someone do this?
I'll look.
Do it.
Didn't we like do this thing last year where we just like count every box and go up and like find it?
Yeah, and you could do that. But sometimes these graphs aren't going to be super friendly. And but yes, you could do that. Yes. This is going to lead me into the next section. What happens when you don't have a graph? I don't even remember which way I'm going to do it. I think it was this way. Okay. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I do that for every one of these problems. All right, x sub 2 is 4, -6, 2, and 4. Y sub 2, y sub 1, x sub 2, x sub 1. Okay, what's 4 minus -6? Yeah, it's really 4 plus 6. What's 2 minus 4? -2. What does that simplify to? -5. Did it work out? Do you guys know why it works out? Why does it always work out?
It's always possible.
Because we said so. Well, what is the slope? It's a comparison of two numbers, right? Vertical change over horizontal change. And that, does anyone know what a comparison of two numbers is called? Don't worry, we'll get this in a future chapter. Starts with an R.
Ratio.
Ratio. It's a ratio. And it doesn't matter if you're going left or right. It's always going to be true. So -5 would be your answer. How many of you got that? You guys are so good. I'm going to give you numbers.
100.
Yeah. Do number 26 and number 30. So do number 26 and number 30. And I'll have somebody do it on the board.
Would that be homework? Supposed to?
No. But, I mean, it could have been. So I'll give you hope. Okay. 26. Who wants to do it on the board? The next person to look me in the eyes will come up here. Oh, yes, Matthew. You will do number 26 on the board. Work it out on your own paper, and you can bring your paper and then copy it up here.
So in the order here is X and Y.
It's always X and Y. And number 30 will be worked out on the whiteboard by the next person to look me in the eye. Yes, Elijah, you have been selected. It wasn't me. So what I'll do is I'll help you guys out just a little bit. I'll put in the parentheses. You're going to put in the numbers and then work it out. Yes, sir?
Are we doing 26 and then what's the other?
And 30. Yeah, I should mark it up here. Number 30 as well. So, boys, whenever you're ready, just come up here and work it out. Time for a commercial break. How about them Niners? End of commercial. All right, let's keep working. Oh, Warriors. Oh. For now. I was actually talking to Coach O, and I was like, Coach, I've been fortunate. Growing up in the Bay Area, so in a few years ago, the Giants baseball, they were winning every other year. Every other year. They stopped. Their dynasty's done. Then the Warriors picked it up and won a few championships for our location. They might beat them. We don't know. But another team rises up to the challenge, the 49ers. Oh, he's good. He's good. Oh, man. Yeah, I'm waiting for the playoffs, though, because that's when it counts. Same thing with any team I watch, including the Warriors, when they get there. As they will get there. Kobe. All right, for 26, the work looks good. The numbers are good. -3. How many of you did not pick this order pair? So your order pairs would have been, make sure I say this right, -2, 2, and 0, 2, -2, 2, and 0, -4. Did anyone not pick those order pairs on number 26? Okay, yeah. Because you could have picked other order pairs, it would have worked. All right, but -3 is the answer. All right, what about this one over here? Oh, decimals. Oh, that's a nice one. Why did you pick 0.5? Who was it, Elijah?
Because -0.5.
Yeah, or yes, -0.5. Why did you pick 0.5, a decimal?
Because it's -0.5 y. One square below x, which would be -0.5.
Wait, what?
Okay, that's cool. So what were those little tick marks on that graph going by? Is I guess what I'm asking.
Oh, I don't know, but if I just saw that it was a horizontal line and I put 0, is that fine?
It could be fine. Yeah, there you go. I didn't even say anything. Yeah. Okay, that's fine. Number 30 would be because by the way, all horizontal lines have a slope of 0. So number 31, give me the answer.
0, 0.
No.
-0. Wait,
Zero.
I'm waiting for the word. It's in your notes.
None.
Undefined.
Undefined.
Zero's the same thing.
No. Okay, here's really. Can I show you what undefined means? Because you guys are honors now. Okay. So, how many of you are of the same opinion that 0 and undefined are the same thing? I mean, just be honest. All right. So, 0 means this as a fraction, right? It means 0 over any number. So I'll just pick 3, right? And that's always going to give me 0. Okay, let's look at a little fact here. I can check this real quickly. 0 divided by 3 equals 0. That's true because what's 0 times 3? Right? You can check division with multiplication, right? Okay, so now let's look at the other one. Let's say it's 3 over 0 because that's what that slope is. It's saying it really has, and you'll see why 3 is not even sufficient. You can pick any number for the rise, but there's no run. Do you agree that there's no run? Okay, what does that equal to?
0.
Okay, ready? What's 0 times 0?
0.
That's not it. So what number is going to fit here times 0 that's going to get me 3? There. Oh, gotcha.
No, but like
Go, guys.
0 slope.
That's 0 slope. That's an undefined slope. I know. It's tricky, but it's true. Your calculator could do this any day. Calculator hates this
Why?
because it can't find a number for it. There's no number. Yeah, it says error or divide by 0.
It's actually a paradox to the calculator.
Say undefined.
Negative 0 to the third.
You can't divide by
Yes. Don't worry, you have some time. Okay. How many of you have a question with 26? Any questions on 26? I think you guys got that one. How many of you did not get 0 for that last one, 30? Okay, you guys okay with that? All right, now let's move on to the bottom, number 30. Actually, let's see which one I'm going to start with. Number 33. Okay, find the slope of that line that contains the given points. And then describe the line we can just do verbally. Okay, so I'm going to find the slope of a line given the points. How many of you think these problems are harder than the last problems? I think they're actually easier because they gave you the points. So now you use the points and do what you can for number 33. Just do number 33 without any guidance, right? That's okay. What's your M value?
Negative 1/3.
Good, negative 1/3. What does M stand for again, guys?
Slope.
Slope. So if they say M equals blank, you're going to find the slope negative 1/3. How many of you did it with the 2,7 in front of the 11,4? And did you get the same answer? Yeah, it's because it's a ratio, so it always will be true for that number. These are easy, aren't they?
Yes.
Good, because I'm going to give you now number 36. Don't say it out loud. Get your answer. Keep it to yourself. I'll come around and see how you're doing.
36?
Yes, 36. Oh, I don't know if it's, I can't say if it's a function, not.
Does that even matter?
What did I say about your answers? Keep it to yourself. I see a common trend here. Okay, I see the answer, but I also see other things on that paper, on those papers. The answer is a simple undefined. It's undefined. Now, Darius, although I didn't ask for this, do you guys notice anything about those 2 points? Do they give you a function or not a function? Not a function. What kind of line is this just by looking at the points? It's a vertical line, vertically up and down. So is it going to pass that vertical line test? No, it's going to fail right there. So it's undefined, and it's not a function. So is it a linear function?
Yes.
Is it a linear function?
No.
So is it linear? Is it a function? So it's not a linear function. A vertical line is not a linear function. And by the way, in your notes, it should say a linear function is any line that is non-vertical. Do you guys remember me putting that? You can look at your notes right now. Any non-vertical line. It cannot be vertical, but you can still describe it with the slope.
Horizontal, it's linear.
Yep, because it passes the test and it even has a slope. Sorry?
It does have slope.
Yeah, remember? It's 0. Yeah, I know that seems like, wait, it doesn't have a slope. No, it has one. It's 0. Yes.
What if it had a number like 4 over like 0, 0, 0, 0, 0, 0, 0,
A lot.
0, 0, 0.
So what do you get?
My brain's already.
Yeah, it'd be like, so this is vertical and like that one would be like something like that. It still has a slope. Okay, the ultimate toughest one that I will give to you is found on page 111. Actually, you know what? Thank you, Andrew, for that idea. Page 112.
Okay. We're going to big boy episode.
Yes. Do it for Carrie's monthly calling plan, and I will describe what that even is. I want to find a slope. Yeah. Do it for the graph. Notice that the divisions are not by ones or by twos, they're by tens, and they're by tens on both. So this is what it was. When I first got a cell phone, when I was in college, you went to Verizon and you wanted to get a phone plan. So they would say, which one do you want? I want 500 anytime minutes. So you bought minutes. You bought how many minutes you could use on the phone. So Verizon came up with a great idea. You know what? You can use those at any time, but from, I think it was like 6 o'clock p.m. for the rest of the night, you have unlimited time because that was their off-peak hours. But if you use it between 8 and like 6, you could use those anytime minutes. If you went over your minutes, you had to pay per minute. And it was like, sometimes like 5 cents a minute. You're like, that's cheap. Do the math. If you're calling your best friend and you're just blah, 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 or you're calling your mom and just telling her about your day or whatever. Long distance calls had a different rate. So anything outside of your local region. And they used to do that per minute. And then someone came up with the idea, let's not charge per minute, go unlimited. And then they went to that place. Then everyone started offering unlimited. And they did that with data.
They still do that.
They do that.
They still do
Like track phones.
like cell phones.
Oh, yep. Landlines, they call it.
Have you seen a phone in a car, Mr.
Yes.
That's like ancient, kind of.
That was cool back in the day. It's like, whoa, they got a car
I
phone.
did have
Back in the day, guys. And when you used to connect to the internet, you would use your landline phone. So you couldn't use your home phone because it was connected to the internet. All you would hear is this weird noise.
That's actually
Oh, sorry. Oh, man, that's bad. Imagine hearing that. I want to call my friend. You pick up the phone. Someone's on the internet. Hang up. Back in the day, that's what happened. That was not too long ago. It was like, because I'm not that old. All right, I got an answer for number 44, basically. What? Yeah, it's number 44 because that's Carrie's monthly plan. All right, go ahead and start if you have it.
When it says, what does it mean? What do you mean?
No. I'm asking you for just what is the slope of the line. So just find that. And then what does it mean? We could talk about that real quick.
Where is B?
No, you don't have to do B. No. Although you could with that, and we'll show you how to do that one. Real quick, just to end this lesson. Okay. You could have picked many points. I think I see like one, two, I think 3 good points, but some of you may find others. Okay, your slope is going to be positive. Like there's no doubt in my mind it has to be positive. Why? Because from left to right it goes upward. So please don't give me a negative. In fact, all of these you could just look at and say positive, negative. Okay, but the rise is 1. The rise is 1. The run is 2. So 1/2. Positive 1/2. Are we good with that? Okay, now what does that mean? For this Carrie's monthly cell plan, every minute she uses is 50 more cents. That's extreme. Bills were getting to the hundreds, 800, 900, 1,000. People were paying that in their phone bills in a month. That's awful. So thankfully we don't have that
Yeah,
anymore.
but why is it saying in dollars?
Oh, because it's saying her price, like $40, $50. Like it could have meant 40 cents, 50 cents, but they're saying in dollars. Good question. All right, B, this month she uses an additional 28 minutes. How much is her bill? What you would have to do is this. You would do 1/2 that slope times the 28, and that gives you your, she would pay 54 more bucks. Sorry, her bill would be 54. She'd pay an extra, I think it's 14 bucks. Yeah, 14 bucks. Her bill is $40 a month, no matter what. If she uses 28 more minutes, it's 14 more bucks. That's a lot. 14 more minutes.
Oh, that's what that means?
Yeah.
Oh, like people.
Yeah, well, okay, let's look at the graph because I'll help you interpret it. Her bill starts at $40, like that's no matter what. And then additional minutes, you can see they go up as her, or the additional minutes go up, her price goes up. So how much is she going to pay if she went 40 minutes above her plan? How much is she going to pay for her? 60 bucks. That's how much she pays. Oh, by the way, you also had to do it for text messages. It was like 10 cents. And text messages included sending and receiving. So if I sent you one, 10 cents. If I got one from you, 10 more cents. So people send you text, you're paying for it. Stop sending me text. I'll call on the off-peak hours. Stop sending me text during on-peak hours. I don't think they really had that because of that. All right. Let's go to 5-2. And we'll finish this up this afternoon, but let's see if we can get it now.
Wait, so we don't have homework at 5-1?
We have
Hey, but back then gas was cheap.
All right. When we're talking about direct variation, guys, we are talking about a specific type of graph that deals with slope. So we're like, wait, this is not slope anymore. I want the first person, when I'm talking about it, to tell me when I start talking about slope. I'm not going to say slope, but once you see something that's like, wait, that is slope, just raise your hand and tell me that's slope. That's what you're talking about. All right, here's the formula for direct variation. Okay, that's your formula. Yes, sir. Yeah, where? I
Right
want
there.
where?
on the screen.
Yeah, which one?
The
Y.
Y.
No.
The K.
Nope. Oh, sorry. Yes. I was ready to say no. It's K. This is your slope. That's what we're looking at. That's your slope.
Wait, why is it not M?
That's a great question. When you have a K value, when I say K equals blah, whatever, you're talking about a slope, but a specific type of slope, one that relates to direct variation. Okay, so it relates specifically to that, because you can have other types of slopes that are not direct variation. This one is. Okay, so here's what we're going to do. Do you guys see that graph, textbook reading? They have time in minutes and pages. Do you guys see that?
Yes.
I hope you understand that the more pages you read, the more time it takes. Is that okay? Total time. So the more pages you read, the more time it takes. That's why the graph is going positively. Okay, why is a direct variation different? Where does my graph technically start? Look at this. Look at it and think about it. Where does it technically start? Where does a person start when they're reading a textbook and the time it takes?
Page 1. Or 0 minutes.
It starts at 0 minutes with 0 pages, don't you? You just start up. You haven't read any pages. You haven't messed with any time. There is a starting point, and it's 0, 0. That's also true of direct variation. Starting point, no matter what you're talking about. I'll put here starting point. Do all graphs start at 0, 0? No, we had a graph we just looked at that started on 0, 40, I believe. Yeah, 0, 40. So that's not a direct variation. This one is. Okay, this K value, so I'm going to refer to it here. This K value is called the constant of variation. What's another name for it?
Slope.
Slope. Slope. So constant variation, also known as slope. But it's a special one, so that's why we call it something different. one way to find that, oh man, guys, this is so cool. We've already done this lesson. We've already done it. We're just going to put things together and see if we can think of direct variation. But let's do it like this. Do you guys see those points on that graph? Can you give me those ordered pairs real quick? Someone give me the first ordered pair if you're reading it from left to right. What's the first red dot they gave you? Yes, Nelson?
Wait.
That's okay. The first red dot, what is it?
820.
820. Yes, 820. So I'm looking on page 120, excuse me, page 120 in your textbooks now. Minor detail, I guess. Yeah, sorry. Page 120 of your textbooks. I have your workbook and textbook in one book. That's why it's strange to me. Like if I turn the page, it's 5-1. So that's why it's weird. Yeah. Okay. Give me the next point. So Will gave me 820. I need another point. The one right to the right of that. And give me that next point. Yes, Michelle? 1230. Good. Yep. 1230. And the next one, I think there's one more. Drew?
1640.
1640. All right, you know how you interpret those points? And I'm going to make sure I say this right. If this person reads 8 pages, how many minutes does it take them? 20 minutes. If they read 16 pages, it takes them 40. Now, are you guys noticing anything about the numbers? They're pretty...
Even.
They're even, but they're pretty constant. Okay, and you're like, what do you mean by constant? Okay, I'm going to find the k value of these points by using this formula. Okay, ready? That's the little equation, that's the little formula. But I want to find out what k is, right? I want to know what k is first. That's what you're going to do on these problems. What is that constant of variation? What is the relationship among all 3 points? Okay, before we do that, do you guys know how to solve for k? It's kind of like your distance equals rate times time.
Divide
You guys
by X.
divide both sides by x, and you're going to get y over x equals k. Is that correct? What does y stand for? Oh, 2 minutes, so we're not done. What does y stand for? Which
Slope.
y stand for? The y-axis, right? What does the x stand for? It's talking about your rise over your run. Okay, and you're like, what do you mean? All right, let's use a first ordered pair here real quick. What's the y value? 20. What's the x value? 8. What does that equal to? If you simplify it into a fraction?
Would be 5 over 2.
5 over 2. Okay? That's my k value for that one. Okay, let's pick the second point. Let's find the k value for that. So I found one k value. Now let's find the second k value. So which number goes on top? The y value, which is what? 30
12.
over 12. What does that simplify to? 5 over 2. That's your k value for the second order pair. Guess what your k value for the third order pair is? Yeah, and you're like, wait, how do you know that? 40 over 16. And you're like, what goes in? 8 goes into both. 5 and 2. I said you did this before. Do you guys remember doing this before? Can I show you real quick? Real quick. You don't have to draw this, but here it is. And then I'll let you go. 8, 20, 12, 30, 16, 40. Do you remember doing that? That's what you're doing. Same thing. Bye-bye.
And then it'll be 20.
You can do 2050.